So Larry, in a previous segment we were discussing furnaces, different options for homeowners, and when we were talking about the 98.5% efficient furnaces that are out there now, you said if you're going to consider that, consider heat pump technology as well. So in this segment, let's explain heat pump technology and then the components that make up a system.
Taking a look at what a heat pump does, if we look at an air conditioner, we know we actually take heat from inside the home and expel it outside. What a heat pump does is the reverse of that. Even in the wintertime, there's heat in the outdoor air. We grab that heat that's available outside, transfer it back indoors through the coil, and actually put that back into the space inside the house.
And so the beauty of a system like this, a heat pump, you can heat and cool throughout the year?
Exactly. The unit that's sitting outside does two purposes. In the summer, we're going to air condition very efficiently the home. In the wintertime or fall and spring, we're going to utilize that same unit to be able to actually extract the heat from outside and put it into our home.
So if it's 40 degrees, 20 degrees, heck, even down to 0, you're telling me you can still extract heat out of the air?
Exactly. Take a look at your refrigerator or freezer at home. If there wasn't heat still present, your refrigerator or freezer, once it ran once, it could shut off. There's still heat that is being available for us to use in the outdoor air, and that's where we're getting that from, all the way down to actually absolute zero.
Well, we talk about evolution in different industries, and it's great to see the heating and cooling industry evolve, because I know 20 years ago, heat pumps didn't have the greatest reputation here in our northern climates. Have they made advancements to make them more feasible for a homeowner and more efficient?
Yeah, the similar advancement technology we've talked about with the furnace side, they've made with the heat pump side. Better electronics, better intelligence to know how to get them to operate specifically for our conditions in the home. And that's really where it's made some great headway.
So in our climate, with a heat pump system, do we still need a secondary heat source?
Ideally we do. There are limitations to our heat pump system designs that we will not be able to get enough heat comfortably into the home as we get down to that 15 and 20 below outside. So normally we would have a backup, and that's where the gas furnace comes in, or you could have electric. We like to see the dual fuel, which gives us the opportunity to use the gas or electrical for the heat pump side, depending on our costs, which vary regularly over the year or year to year.
It sounds like a very intelligent system and more consistency for a homeowner.
Exactly. It's going to save them with a great return on investment.
Okay, what are the components that make it operate so efficiently?
Let's look at that. We've got a unit tore down over here we can show you. What we've done is we actually removed the fan that sits on the top, and we've got it sitting here on a table. Inside the unit is a compressor here in the center. That would be the same whether we have it for an air conditioner or, in this case, a heat pump. So this is the device that actually moves the refrigerant through the system. A couple extra components we see in here versus a standard air conditioner. The bronze or brass looking device, that's the reversing valve. That's the device that reverses the flow of refrigerant, which turns the system into providing heat versus cooling, summer versus winter. And then the other device, this is an accumulator, not a big deal, but it's necessary for when we change modes from summer to winter. It allows us to adjust the proper refrigerant charge for the unit automatically.
Well, I have to tell you, I've always wanted to look down inside here. There aren't that many components, but I bet the technology that drives these components and controls them really make the difference.
Yeah, a lot of it now is done solid state through the controls that are microprocessor based, and it's made a huge advancement in what we can do with the systems and how much more efficiently they perform for us in our climate. You had mentioned 20, 25 years ago some issues. It was typically tied to the defrost cycle. Now we've taken the complexity away from doing it electromechanically to now doing it electronically with the use of computer technology to be able to intelligently know when is the right time to defrost.
Boy, it sounds complicated, but is it easy for a consumer to control these systems? In other words, is it just a simple thermostat on the wall?
Yeah, the beauty to the homeowner, they really don't have to change a thing. They set the thermostat the way they want it. Today's internal components and electronics take care of the complexity and takes it away from the homeowner to ever even worry about. Normally the system will operate between using a heat pump or going back to its backup heat source, customarily a furnace. It'll do that automatically, and in most cases the homeowner will not know which mode or which system is actually providing the heat, which is ideal. You don't ever want to know that it's switched modes.
Okay, well this all makes sense to me. So I'm a homeowner, I'm considering heat pump technology. Are there different options I have to discuss with my contractor?
Yeah, there certainly are. There's basically three different types. You have an entry-level heat pump, like what we would have sitting here. What this is a single speed compressor, turns on, turns off as it needs to. This will give you good efficiency, good performance, but it won't get you to the ability to heat majority of the time through the use of a heat pump. It has its limitations.
Okay.
We then move up to a two-stage model, which we saw tore apart over here, which better matches because now we can run low speed for our cooling and mild fall conditions, and then go to high speed as it gets colder out. And finally, we jump up to our green speed technology. We talked in the furnace segment about the modulating variable speed blower technology we use in furnaces. We've now incorporated that same technology within the fan as well as the compressor today. This will allow the compressor and heat pump to actually modulate from off fully 100% as it gets colder out. As we get colder out, it will speed up to do more work to transfer more of that heat indoors as our need goes up because it's getting colder.
Wow, so the intelligence that's been built into this system, it's monitoring the outside and inside environments to maximize the efficiency and comfort for the end users.
Exactly.
Okay, so this would be considered air source heat pump technology. How does it differ from geothermal?
Glad you asked. Actually, they're both heat pumps. This happens to be an air source heat pump where we're extracting heat out of the air that's outside. Geothermal, we extract the heat out of the earth, whether we're pumping water and extracting it out of well water, or whether we're using a closed loop tubing system buried in the earth to extract the heat out of the earth. Now the ground temperature, as we know, stays relatively constant. Sure. So you're going to have better overall performance from a geothermal than you would from an air source heat pump in most cases.
Sure, and of course with geothermal, you're talking about extracting it from the ground. You need a loop field, and so it might be a little more upfront cost there for the homeowner.
Much more upfront cost to the homeowner with geothermal versus green speed.
Okay, so with the advancements in technology, the air source ones work now in our northern climate. Geothermal works. As a consumer, which one am I to choose? Which one's going to be right for my situation?
Great question. The big thing we have to look at is a loop field capable on your property? Depending on your ground condition, depending on location, is it really feasible to put in? Do you have the money for the first cost to be able to do it? Whereas with an air side heat pump, you can pretty much put this anywhere, whether you're in the city limits, whether you're out in the country. You have the flexibility here of not needing to tear your ground up around your home to put in geothermal. This just sits on the side of the house just like your normal air conditioner does. Biggest difference is we do set it up on a little bit higher pad because you do have to, in the wintertime, be able to drain some condensate off of it when we go through the defrost modes.
Well, it seems to me like they're both viable alternatives to just a fossil fuel burning furnace, that's for sure. And more importantly, it's a good example of why you want to keep your lines of communication open with your contractor. I mean, there's a lot of technology going on here. Lean on your contractor, see which is right for your situation. But either way, whether you're talking geothermal or air source heat pumps, seems to me it's a great option for homeowners considering choices for their home and getting the most efficient, most comfortable systems to live in.
Exactly.